Hey everyone, on the home stretch towards exam number 2, this is reading recap 7. I'm just so good at counting. We're going to start off on page 435. And as we talked about in lecture on Tuesday, we're now moving into not only do we get mutations, but how do we repair these mutations? So on 435, we actually start off with base excision repair. Mismatch repair we read about yesterday. No, we read about for lecture on Tuesday, but we're going to discuss that in lecture today. But in the reading, we go over basic excision and repair. We focus mainly on the prokaryotic system. Know that there's slight differences in the eukaryotic system, but really what I want you to get from the reading is the overall gist of the NER or basic excision pathway and what it is used to repair. So if I go ahead and turn the page, I'm going from 435 to 436. There's a little minor point that I have about the uracil glycosylase, know what it is, know how it works. We will go over it in lecture. On page 437, we move on from basic excision repair and get to nucleotide excision repair. Once again, you don't necessarily need to know all the little tiny details about how this works. I want you to get the general gist. Something that is cool that I do want to point out about the NER pathway is that it has an X nuclease, which actually makes 2 nicks in the DNA instead of just 1. So it's something, fun fact, pretty cool. Now I want to skip over to page 439. On 439, there's a highlight about xeroderma pigmentosum, which is one of the diseases that we'll use to understand UV-induced DNA damage. We will talk about this in lecture, but it's a nice place to get the full story and context for that example. And then to 443. 443 to 444. They're two kind of like how we know experiments behind some of the things that we're teaching. For the exam, you don't need to know it. Hopefully you read it, but you don't need to go back and study these 2 pages. Okay, now I'm going to go over to page 449. 449. Okay, 449 has an opening story about a moment of discovery. For testing purposes, you don't need to revisit the story, but once again, I really do hope you read it. It gives you really great context, some of the history of how we understand or how we know what we know about cell and molecular biology. Then we go ahead and we turn over to page 450 and we start talking about double strand breaks and how they occur. What the hell that is? Double strand breaks and how they occur. So take the time to read that area. It's going to be important for you to know. And then you see this figure over on the next page. This page, 451. We are going to go over this figure in class, but it's also a great one to know to understand the different ways in which a double strand break can lead to, I guess, collapse of a replication fork. That's really what we want to get out of this figure. Now we're going to head over to page 452. And so this is just one page over. Make sure it's in here. Okay, so on 452, we actually get to homologous recombination. I highly encourage you just to go over starting at double strand breaks are repaired by recombination and just have a general workflow of what the steps are in homologous recombination. And I'm going to ask, like I said, I'm not going to ask you to know all the details of homologous recombination, but to know why it's used, what type of damage it is used to repair. And then on the flip side, if you jump all the way over to page 475, 475. We just did homologous recombination, and then now we're basically running into non-homologous end joining. And so this is another way to repair large structural breaks in chromosomes. But one of the differences is that, NHEJ or non-homologous end joining is mutagenic, and we tend to use it not during the replicative phase where you have a lot of sister chromosomes that you could potentially match and use as a template. So what's going to be important is being able to compare and contrast both homologous recombination and non-homologous end joining. And there is going to be some extra slides in Canvas that compare and contrast the two, and we will also talk about that in class, and you will see it on the exam. So I'm excited for class today, and I will see all of y'all in a couple of hours. Bye.